So let's take a look at all of the different terms that make up our level measurement scaling and how that reflects in the LT500. First, we have a simple tank here with an amount of liquid in it. And at the top of the tank, we have our sensor, which is just represented as a basic triangle here. That's our sensor reference point. So that's where the sensor is installed on the tank. From there, we have our upper calibration and our lower calibration, and that corresponds between where the bottom of the tank is to where the top of the amount of material that we will measure would be. So the distance from the sensor to the upper calibration point is where the material will normally be at 100% of capacity. And those two may be the same reference. That sensor could be right on that upper calibration point. In a lot of cases, it is not, especially with ultrasonics where we have a blanking distance that we need to consider. So from the sensor to the bottom of the tank, that's lower calibration. From the sensor to the top of where the material will be, that's upper calibration. The corresponding level values of those are upper level and lower level, again, from the bottom of the tank to the top of where the material will be. And those correspond with the upper range and the lower range, which are the milliamp outputs of the device. But we'll talk about that more in a minute. From the sensor to the top of the material, that is what we call the distance measurement. From the top of the material to the bottom of the tank, that's what we call the level measurement. And from where the top of the material could go to, or 100% capacity, to the top of where the actual measured material is, that's what we call space. So those are the three different PVs we have for your basic level measurement: level, distance, and space. And you can see those there as well. What we do with the LT500 and all of our newer products, the LU240, etc., is we do a percent between lower calibration and upper calibration, and we apply that same fraction of percent between lower level and upper level. So let's say we had a tank and from 0 to 10 meters is empty to full, and we were right in the middle, 50%. 50% between lower cal and upper cal is what we would apply to the lower level and the upper level. And that's what I'm illustrating is we can play with those numbers in the LT500. And after you run a quick start wizard, and we'll look at this in the product in a minute, we do this for you automatically. But after you've run the quick start wizard, you can go in and you can manipulate those numbers if you need to. Typically, that's not going to be required. In fact, very rarely would it be. The one application that we do get requests for is customer would like to know the reference of their material with regards to sea level. So let's say this tank is 10 meters above sea level. They want to see what that measurement of their material is with regards to where the sea level reference is. So to do that, what we would recommend is entering a level offset. We'll talk a little bit more about that in a second. But what that does is it creates an offset in your level reading, which would then affect your milliamp output. So to give you an example, if we have a 0 to 10 meter tank and we added 100 meters to reference where sea level would be, that would put us far beyond the capacity of our application that we've set up through the Quick Start Wizard. We would go into upper saturation in our milliamp output. So if we do that level offset, we have to make a corresponding change to upper range on our inputs and outputs. And again, we'll show you how to do that in the product. But also to make you aware, there is a sensor offset, and that comes into play if sensors are removed for cleaning and are reinstalled and they're not quite perfect and the reference points have shifted a little bit. That's where we would recommend you would use that parameter, but only in very extreme cases where that's necessary, because as you can see, everything remains the same from the original sensor reference point. It's just a shift in where the sensor has been reinstalled. So let's take a look at how all of these interact with each other on the actual LT500.
So here we have an LT500 fresh out of the box, and I'm just going to go through and quickly do a quick start wizard. Again, use mostly factory defaults here, but for simple numbers, I'm going to make our cal low 10. Oops. And upper cal 0. And we'll make our response rate fast. So again, very quick and easy setup. So go back to our run screen here. And now we see we're measuring. So, and we're fairly close to our upper limit. Now, if I go in and I take a look at the sensor parameters that we were just looking at in our diagram, and I go down to calibration, I can see the lower cal point at 10 meters, just like we set up, the upper cal point at 0, like we just set up. And then we have the upper level point. So again, that's the reverse of our calibration points, because we're looking at the difference between the reference from the sensor to the calibration point versus the level reading, which is 0 at the bottom and then 10 meters at full capacity. So that's the normal setup. Now, if I was to change upper level to, say, add 100 meters in, you'll see that we will go into upper saturation on our milliamp input, and that's what that process value alarm is. And we can go take a quick look at that. If we go back out to our top level view here, we can see the diagnostic is on, and loop current is in upper saturation. So we can come back, and again, to clear that, if we went in and changed our inputs and outputs, like I said, the upper range value and the lower range value, that's what would clear that. But for now, I'm just going to go in and I'm going to set that calibration back to 10. So set that back to 10, and then we'll see that diagnostic at the bottom clear. So it's gone now. Again, we can do the same thing with level offset. So that just changes our reading of the absolute level value. So again, if I added 100 meters there as well, if I wanted to reference, say, sea level or whatever, I would see the exact same error pop up. So again, there's that same upper saturation issue, but I'm going to leave this one at 100 meters. So this time we're going to go back through and we're going to change the upper and lower range value in our inputs and outputs of the milliamp output. So here I can see what my upper range and lower range values are, and you can see they're still set to what I did in my quick start wizard. So if I change my upper range now to, say, 110 meters, that clears my diagnostic. So when I come back out to my top level view, now I'm reading 109 meters before I was just reading 9 meters, and say I've got a reference to sea level now. Now, the one thing to be aware of is that does affect the amount of resolution you have on your milliamp output, but it is a true reading as required versus sea level or some other reference point.